Hi, Mr. Sapone here, and today we're going to talk about mixing aqueous ionic compounds. And we know that sodium chloride is table salt. It's a positively charged sodium cation and a negatively charged chloride anion. When you put solid table salt, when you put a salt crystal in the water, we know that water, which is polar, is going to dissociate it. It's going to separate the sodium and the chloride ions into respective ions. So we end up with NaCl, aqueous, and that simply means that they are separate. We know that it's going to be an Na plus and a Cl minus. These things are going to be completely separate when you put them in water. That's what happens to a lot of ionic compounds. When we put them in water, they separate, dissociate. So what we're going to look at now is what happens if we take two separate ionic compounds that are dissociated in water, and what happens if we mix those two solutions together. So let's say we had an ionic compound AB over here. We have a cation and an anion. We drop it in the water, it dissociates, it separates. And over here on this side, we have hypothetical ionic compound CD. And again, you drop it in the water, it dissociates. They're separating into respective ions. So what I want to know is what happens is we take this cup of water and this cup of water and mix them into one. What do we end up with? Well, we're going to end up with all four ions in water. And sometimes what happens is, and this is kind of, we can write this as a chemical formula, AB aqueous, right, plus CD aqueous. We mixed the two cups. We mixed cup AB with cup CD. And water was strong enough to pull apart A and B, and it was strong enough to pull apart C and D. Occasionally, when you mix two aqueous solutions together, sometimes they will join together. So we saw that AB was bonded together, and water was strong enough to pull AB apart. Water was strong enough to pull CD apart, but when we mix these two aqueous solutions, as it turns out, BC is going to come together. Water is not strong enough to keep B and C apart. So we end up with something new here. We end up with a new substance. We had AB plus CD, and now we end up with BC. And this is going to be a solid. Why? It's not going to be an aqueous anymore. It's going to be a solid particle. It's going to be a precipitate forming in the solution. And that's because they bonded together. They electrostatically attracted. Water could not keep B and C separate. And we'd write that as AB aqueous plus CD aqueous yields, that's what the arrow means, AD aqueous. A and D are not doing anything. They are staying here. They didn't do anything. They were in the solution. They're actually going to be called spectator ions. They didn't do anything at all. They just stayed in the solution. But B and C came together to form a solid precipitate. And sometimes that happens when we mix two aqueous solutions with dissolved ionic compounds in them. Sometimes we get a new substance forming. So let's take a peek at what happens when we put sodium hydroxide in water, copper chloride in water, and then mix them. So on the left we have sodium hydroxide, NaOH, going in water, and it's going to dissociate. And the copper chloride is also going to dissociate. So we're dropping them in, and we have dissociation. We now have aqueous solutions. We have an aqueous solution of sodium hydroxide, NaOH aqueous right there. And we have copper chloride aqueous. Everything's separated, dissociated. So our idea is what happens now if we mix these two things together. And as it turns out, water was strong enough to separate NaOH. Water was strong enough to separate copper chloride. But copper really, really loves hydroxides. So this copper and this hydroxide will join together to form a solid if we mix these two solutions together. So we're pouring them all into one container. And when we do that, we have all our ions in there. And the copper and hydroxide are going to attract to one another. And that is a solid precipitate forming. So that's what happens when we mix these two solutions in chemical form. The formula is up here up top. We have NaOH aqueous plus copper chloride aqueous, yielding NaCl aqueous. The Na, the Cl, they're not doing anything. They're just staying there. They're spectator ions. plus copper hydroxide solid. And of course, this equation is not balanced at all. We didn't balance it. If we wanted to balance it, you would need another one of those. And this is actually what would happen. I know this looks like pretty dense, but it's just a balanced equation. All I did was balance it. To balance this, you would need 2 NaOHs plus copper chloride, yielding 2 NaCl plus CuOH2. So the same thing would happen. The Na, the Cls, they're going to stay together, or they're going to stay separate. They don't do anything. And the copper and the hydroxide are what actually come together. Copper hydroxide. These things don't do anything. Spectator ions, copper hydroxide forms a solid precipitate. It's a solid now. So if you mix these two liquid solutions together, it'll turn out you'll get a solid particle, and I believe that would be blue, a little blue solid, copper hydroxide. So let's do one more example of this. Let's actually try to write the formula for what's going on in this picture. So looking at it to start with, we have, looks like we have barium chloride, aqueous. And looks like over here we have sodium sulfate, aqueous. We have two dissociated containers with dissociated ionic compounds in them. The barium separated from the chloride, the sodium separated from the sulfate. Now what happens when we mix them? When we mix them in here, well, as it turns out, the Na and the Cl, well, they don't do anything. They're spectator ions. They're not reacting. The Na and the Cl don't do anything. The Na and the Cl spectate. What happens is the barium and the sulfate join together, and they're little solid particles. They form barium sulfate, a solid particle, and that's a precipitate. So let's actually write this chemical reaction out and see what we get. So we have barium chloride, aqueous, right? That was over here. That's our barium chloride aqueous. That's one. Plus sodium sulfate, and that should be aqueous. There should be a little aqueous up there. See if I can get a different color pen. We can. This should be AQ. And that's going to yield 2 NaCl aqueous plus barium sulfate solid. So we have a solid particle there. And that's how we would write that reaction. I know it looks a little dense, but with a little practice, they'll get a little easier. Again, this is aqueous right here. That's a Q. It doesn't look like one. That's what this picture is showing. Barium chloride combining with sodium sulfate, and it's producing solid barium sulfate. The barium is combining with the sulfate anion. And that's what happens when we mix ionic compounds. This is Mr. Zapone. I'm out.